All right, this is lesson 4.1. This is the third day, a little bit of a review, and this is an optional one, so if you feel like you know what you're doing, you didn't have to watch this one. We're just going to fill out the rest of that packet. I know Joey is watching, but if the other people aren't watching, that's okay. So let's just kind of click through this and see where we're at in that packet. We had done day 2. We'd done the graphs of sine and cosine. That was review. And then we had talked about here the period and how the 2 or the 5, whatever is in here, all those different things, how they can change. Oops, sorry about that. Bring that back up. How the 2 and the 5, whatever's in there, they change how long it takes for our trig functions to repeat. So we did that. And then we looked at a couple examples here. Here's sine of 4x. Here's cosine of 1/3 x. Those look familiar. Those are on your homework quiz today. And then we did a couple where we combined amplitude and period. This first one we'd already done. And in the second one we'll have done today in class. So I want to just quickly show you the last two here. All right, so we've got the negative sine of 4x and we got the negative cosine 1/2 x. So kind of hitting the negatives hard here. But let's start with this first one. We know the number on the inside affects the period. So it's not the period, so I should be careful here. It affects the period. And the number on the outside affects the amplitude. All right, the period we know is the time it takes to repeat. The period is on the x-axis. So we look first for the period, we look at our x-coordinates, or our theta coordinates. It kind of goes x and then y. So we look at our 0 and our pi halves and our pi and our 3 pi halves and our 2 pi. The 4 makes our graph occur 4 times more frequently. So all of the x-coordinates get divided by 4. So we have 0 divided by 4, no big deal, it's still 0. Pi halves divided by 4 is like multiplying by the reciprocal, 1/4. So I now get a pi 8. Pi divided by 4 is like multiplying by 1/4. So I now get pi 4. 3 pi halves, again multiply by the reciprocal. I get 3 pi 8 and 2 pi. You can cross cancel here. And I get pi halves. So multiply the top of the fraction, multiply the bottom and reduce. Or you could have just cross canceled. So my x-coordinates have changed. They've got cut in 1/4 because this graph is occurring 4 times more frequently. My y-coordinate, it's just a negative on here. So all my y's are going to take times -1. 0 times anything is 0. -1 times anything is -1. This is still 0. This becomes 1. And this becomes 0. And with these transformations, considering the 4 and the negative, I can now graph my new graph. So let's set up the x-axis. I want my 4 key points. I've got my 0. Instead of pi halves, this is now pi 8, pi 4, 3 pi 8. Instead of going all the way to 2 pi, this graph occurs 4 times more frequently, so I'm done in pi halves. My y, oops, we got a 1's on here, so I can't really argue with that. I wish that was a different scale, but that's what it is. So let's graph the points. Our first point is 0, 0. At pi 8, we notice the y-coordinate is -1. That brings us right down there. At pi 4, the y-coordinate is 0. At 3 pi 8, the y-coordinate is 1. And at pi halves, the y-coordinate is back to 0. We'll connect these with a nice smooth curve. And we have now graphed y equals negative sine of 4x. Make sure you've got your x-axis labeled. You want those points labeled. Make sure you've got your y-axis labeled. Probably not the best choice for the y-axis, but that's what it was on there, so we'll have to live with that. Okay, let's go on to one more question, and you guys will be in a good spot. There's a couple of things on the homework a little trickier with matching and that. Other than that, I think you'll be able to figure things out, and you probably figure that out too. Okay, same thing here. We look here, the period. This graph is only going half as fast. So I have to take all my x-coordinates and I have to divide by 1/2. Wait, how do we divide fractions? We multiply by the reciprocal. So all of the all the x-coordinates get divided by 1/2, otherwise known as multiplying by 2. So 0 times 2 is still 0. Pi halves times 2, or 2 over 1, I can cross cancel. That now becomes pi. Pi becomes 2 pi. 3 pi halves becomes 3 pi. And 2 pi becomes 4 pi. And you look at those, oh, that makes perfect sense. Instead of 0 to 2 pi, we go 0 to 4 pi. It occurs half as fast. We've got the negative in front. All the y coordinates get multiplied by -1. So I get a -1. Stays 0. I get a 1. Oops. Got ahead of myself there. There's a 0. And there's a -1. Let's set up our x-axis. Have to label these points to show people I know. Look, this is getting stretched out. It takes twice as long for this graph to occur. So 0 to 4 pi, the y-coordinate starts at -1, goes up to 0, higher to 1, down to 0, to -1. Connect this with a nice smooth curve. Let's go blue. And I've got my y equals the negative cosine of 1/2 x. Again, be sure to have your x-axis labeled. Be sure to have your y-axis labeled. So hopefully you're getting a very nice handle on those. This is the first section. And what we'll do in the next section is we'll start translating these whole graphs, lifting them up and down and shifting them left and right. So there's more to this, but you want to have a very good foundation in this part first before we move on to the second part. And that completes this optional part. Thanks for listening, Joey.